And we'll start on our practice final. Make sure we're in the right one. We're on our practice final, and we're going to start off with question 7. So someone asked about question 7. Okay, and this one looks more difficult than it really is. And sometimes it's easy to overanalyze a question like this. When we read this question on 7, the key word to pick up on is average rate of change. And when I see average rate of change, that means the slope. So average rate of change, that's going to indicate our slope. And it says in volume of water per second. So that per, well, that means divide. So when we write up our formula here, we're looking for the average rate of change, which is our slope, m. And that is going to be the volume per second. Now, when we look at this, a volume per second, this is our slope. And our slope, remember, is always y on the top, x in the denominator. So when we create our ordered pairs, our x is going to be the seconds, y is going to be the volume, because there's x and y there. So we want to make sure we match them up correctly. So x is going to be the number of seconds, y is going to be the volume. And y is on the top, so that goes with the volume, because volume's on the top. X is down below in our slope formula, so that goes down below. Now we use our slope formula, which is m equals y1 minus y2 over x1 minus x2. And we need our ordered pairs. And so when we read this, it says we're filling up a water bottle, and after it has been filling for 5 seconds, it indicates 25 ounces of water. So our first ordered pair is going to be 5 seconds, and our volume is 25. And after it had been filling for 12 seconds, it indicates 53. So there's our second ordered pair. Now we've got them, x1, y1, x2, and y2. So now we can just plug them in. So average rate of change, that just means your slope. And so that's 25 minus 53 over 5 minus 12. And we know it should be positive because we're filling it up, right? So the volume should be increasing, so the rate of change should be going up. If it's going down, you made a mistake. And 5 minus 12, well, that's a minus 7. Negative and negative makes it positive, and so that comes out to be 4, because 28 divided by 7, that makes it 4, and that is then in, let's see, what are my units here? It looks like ounces per second. Because ounces is the volume, seconds is the time. So we're increasing by 4 ounces per second when we fill up this bottle. Does that make sense on that one? That one was just a wording question, and if it would have said slope, you probably would have known what to do. But it said average rate of change, which is equivalent to slope. Same as pitch or grade. If you're looking at the grade of a road or the pitch of a roof, those are also the same as your slope. Okay. 11 and 12 I picked because these are piecewise defined functions. And I don't think we really completely covered these. Now, what this is this is a function that's got different levels on it. And they've got a condition that tells you which level to use. And question 11, all we have to do is plug in the number 6 into the correct level. And so we've got 3 equations, and they're all different. And they have different requirements. And we want to find f of 6. And that 6, all right, well, that's going to be your x value. So let's write out in terms of words what these mean on the first one. So the first row, this says x is less than 0, less than or equal to 0. So we're looking for this row would be number 0 or smaller. So number 0 or smaller would fall into this one. The second row is for numbers between 0 and 5. And the last one, row 3, is for numbers that are 5 or larger. So now which row are we going to look at and we're going to use here? Well, we look at our 6. Now 6 is our value of x. So the 6, what is it? Is 6 smaller than 0? No. So it would not fall into the first row. Is 6 between 0 and 5? No. It's not going to be here. Is 6 larger than 5? Yes. So which row are we going to use? We're going to use row number 3. And so f of 6 would then be just simply 6. I'm going to do a couple more examples with different numbers, so hopefully it'll make more sense. Let's try 3 more of them. Let's try f of negative 4. Let's try f of 1. And how about f of 10? So these are just extra examples. Each of these are going to be on a different row. So f of negative 4. Now, the first row is going to be for numbers that are what? 0 or smaller, right? This is our x value here. Is negative 4, is that smaller than 0? Yes. So if I said find f of negative 4, you would simply plug it in to the first row. And if I plug it into the first row, then we get 3 times a negative 4 plus 3. And that's going to be minus 12 plus 3, which is then minus 9. And why are we plugging it into the first row? Because this is the condition here. Negative 4. Well, negative 4 is smaller than 0. So that's why it's going in the first one. What about 1? Okay, is 1 between 0 and 5? Yes, it is. 1 is in between 0 and 5. So that's going to be row number 2. And what do we plug it in? Plug it in here. And that's going to be 3 minus 5 times 1, which is then 3 minus 5, which is then minus 2. And what about the last one? This again is our x value. Is our x value bigger than 10? Yes. What's our function? Simply x. So it's bigger than 5. 10 is bigger than 5. So that means our value and our answer is going to be simply what? Simply 10. So all we did was we figured out which row it fell under. And if it's just got an x here, that's just the number. So these are just examples. So like on our first one, our first row is for numbers less than 0. So if I wanted to find f of negative 4, I plug it into the first one because this is for values of x that are what? Less than 0. The second one is 1, and it's between 0 and 5, so it would go into that one. And if I gave you 10, then you would just plug it in here, and that's simply just itself x. So what you do when I give you these is you just plug it into only one of the equations. Only the one where it falls. This is your value of x, so then these are the conditions that go with it. Do we understand that, or do we need to do another one like it? Do we kind of know what to do? You just figure out where it goes. Now you're only going to get one answer, so only plug it into the correct row. Only one row. I also want you to graph one of these, and we graph these by picking points. And so we're going to go over 12 here. And we're going to be graphing this one. And we pick points, and we connect them together. And I like to label these row 1 and row 2. And we're going to do 2 points in each row. And then we identify whether we use an open circle or a closed circle. So when we go to graph these, greater than or equal to, less than or equal to, those we're going to be using a closed circle on. Strictly greater than, strictly less than, those get an open circle. And sometimes students find it easier to write it out in words. So I know in my first one, I'm going to get an open circle. And what are my conditions here? First one says x is less than 0. So we're going to be looking for numbers that are less than 0. What about the other one? It gets a closed circle when we go to graph it, and it says numbers that are larger than 0. So we're going to be looking for numbers that are larger than 0 for there. Now, what we do is we pick 2 points in each row. We plug them in. Now, we always plug in the value that they give you first. So we're going to always plug in the 0 into both of them. But then we're going to add in extra points after that. And we'll do them independently. And I'm going to do 2 different colors so you can see the 2 different graphs. They're done in pieces. These are called piecewise defined because they have to be done separately. So let's look at our first one. Let's do row number 1. And row number 1, what does it say? It says we want numbers that are less than 0. Now we always start with the number they gave you. So in our case, they gave you a 0, so we're going to plug in 0 first. Always plug in that number that they gave you. So they gave you 0, so we're going to plug in 0. And this is row 1, which is 5x plus 8. We're going to plug in our 0. And that gives you then 8. And this is your y value. And we need ordered pairs. So my first ordered pair would be 0, 8. And we need 2 ordered pairs for each row. 2 for each one. So we plugged in 0. Now, what else do we need? It says we need numbers that are less than 0, smaller than 0. So we need another number, any number that's smaller than 0. And a nice, easy number to pick, you make them as convenient as possible, would be -1. So we're going to plug in a -1 into row number 1. Because these are all going into row number 1. So if I plugged in this -1, that would give you 5 times -1 plus 8. 5 times -1 is -5. -5 plus 8 makes it a 3. That again is your y part. So as an ordered pair, you would now have -1, +3. So let's take a moment to graph this one. Now notice it is less than 0. So that means we're going to have to be using an open circle. And what we do is we just plot our points. And we're at 0, 8. And we're going to be using an open circle. So let me make sure you can see that that's an open circle. So it's clearly an open circle here. and that is at 0, 8. Our second point is at -1, +3. And we connect them together. So we just simply connect them together, and this makes half the graph. Right? It's for values of x that are less than 0. So less than 0, the graph looks like that. Okay, there's that piece. Now, we need to repeat the same process with the second row. So when we go back up here and look, what's our second row? Our second row is a square, and it says it's 3x squared minus 5. And we're going to start by plugging in 0. So we're going to plug in 0 here into our second row. And that's 3x squared minus 5. We're going to plug in our 0. And that gives you then a minus 5. So that's our first ordered pair, which is 0 minus 5. So there's that piece. Now, what about that second row? What values of x does it need? Well, according to our condition, it needs big numbers bigger than 0, right? So let's pick the next number larger than 0. How about we pick 1? And if I pick 1, that's going to then give you 3 times 1 squared minus 5, and that's 3 minus 5, which is then a minus 2. As an ordered pair, that would be 1 minus 2. So now we have our 2 points. We're going to plot those 2 points, and this one gets, remember, a closed circle. Because of the greater than or equal to, it gets a closed circle. So we're going to start at 0, -5. And that one's going to get a closed circle. The closed circle and open circle are always on top of each other. Our next point is at 1, -2. So that's right there. And it's a square, so we just kind of curve them together like that. And just kind of curve it a little bit because it's a square. So you just pick 2 points, work them out for each row. And you could expand this out to 3 or 4 different equations. I'm only giving you 2 equations. But it could be expanded out further than that. I think that takes care of all the brand new material. That was the only ones we really haven't talked a whole lot about. 16 and 17. I picked these just to make sure we understand the terminology and what to do. So for 16, we're not going to be solving it. What we're going to be doing is we're going to be finding the domain. So we're going to be finding the domain of these functions. And these functions are going to be multiplied together because we're looking at f times g. So we're not going to be cleaning it up. We're not going to be doing a lot with these. We're going to be simply rewriting them, and we're going to be looking for division by 0 because all we are doing is finding the domain. Domain is the parts of division by 0. So we want f times g of x. And that is f of x times g of x. And you are given the 2 functions. So you're given f of x, which is 2 over x minus 6, and you're given g of x, which is minus 7x minus 5. Now, we do not have to clean these up. We don't have to do a lot of work. All we have to do is put them together. So f of x is 2 over x minus 6. G of x is right here, and it's a minus 7x minus 5, and that's going to be over 1. We put those together, and you can just leave the 2 out in front. Now, do not overcomplicate this question. We do not have to break it up anymore. We do not have to do anything else. All we have to do is find the domain. Now, what numbers are not in the domain? Well, numbers that are not in the domain, that's division by 0. So we, remember, cannot have division by 0. So we don't even care about the numerator. The top half doesn't even matter. All we care about is that denominator. And what number is not in the domain? Well, not in the domain would be x plus 6 equals 0. So x equals a negative 6, and that is not in the domain. Now, how do we write our answer? Well, we write our answer as negative infinity to negative 6 union negative 6 to positive infinity, because that's how they want you to write the domain. We need to find out what number is not in the domain, and we write it out. That's it. It looks more complicated than what it is. The main thing I want you to take away from this question is what's the domain.
So you have it as x minus 6.
Oh, did I? Oh, my mistake. I wrote it down wrong. So that'll make that then when I move it over. Yep, sorry about that. Yep, just not thinking today. Okay, so I move that over. That makes it a positive 6. So that should be your domain. But do you see what we... Now, if it was like 3x plus 9, then you would solve it, right? So we don't have to do anything else but look for division by 0. When it says find that specific domain, you find the numbers that is numbers that are not in there, and then you split them up. Because this says every number is a possible solution except for positive 6. Because positive 6 would give you division by 0. Question 17. When I worked it out, I actually worked out extra things that you really don't need, because I got the entire circle, but all you really need to do is find the radius. Now, how does the diameter and the radius relate to each other? So what you're given is you're given a diameter. And remember, the diameter is double the radius, or the radius is half the diameter, which is what we're going to be using. So we need that fact that the radius now is going to be half the diameter. How can we find the diameter? Well, the diameter is the distance from 2 points on the circle. Two points that are opposite on the circle. You draw a straight line through them, you get your diameter. So they give you these 2 points to work with. So a circle has a diameter with endpoints minus 2, 1, and 22, 11. Now you could get the center by using the midpoint formula. But I don't ask for the center, I ask for the radius. So the radius is a distance. So we're going to need our distance formula. And the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. x1, y1, x2, and y2. Plug our values in. Watch out for double negatives if we have any. So we've got minus 2, minus 22, quantity squared, plus 1 minus 11, quantity squared. So that's a 24 squared and a minus 10 squared. Remember, when we square negative, it becomes a what now? When we square negative, it becomes a positive. So that's 576. 10 squared is 100. Remember, this is still underneath that root. So that comes out to now be the square root of 676, which is a perfect square of 26. This is not the answer, though. This is the diameter. Right? The distance across that circle is the diameter. We don't want the diameter, we want the radius. And so how do we find the radius? Well, the radius, remember, is the diameter over 2. So that's 26 over 2, which is then 13. And I went through and I found the midpoint as well. You don't need to. All you need to find in this case is the center. But I think I worked out and got the entire equation. You don't have to do that. All you have to do is find the radius. Because when I worked it out, yeah, all you had to do, you could have stopped here, right? But I actually worked it out and got the entire part. I got the center and I got the radius both. But all you really needed in this case was the radius. So is everyone okay with how I did that? Just use the distance formula, half it, and that gives you the radius. So that takes care of that question. And what I'm covering is the ones I know we struggle with. After we're done with these, then we can go back and answer any other questions that you have. So that was 16 and 17, which are done now. We only have a couple more. We're going to look now at 28. (28). (28's) a really easy question, but you may not understand exactly what I'm looking for here. On 28, we're working backwards. So I'm giving you the answers, and I want you to tell me what equation they came from. So I'm going to work out 28, and I'll probably do a couple more examples just to make sure we understand what we're doing here. So this one was with imaginary numbers, and I'll do this one. I'll probably add on 2 more just to make sure if I change it to real numbers that you'll know what to do. Now in question 28, you're given these. You're given 4i and minus 4i as the answers. Okay, so these are the answers, and we want to come up with the equation that it came from. So each one of these is a solution. So what we're going to have to do is we're going to have to take each one of these, and we're going to have to rewrite it equaling 0. So x plus 4i equals 0. That gives you x equals a minus, or sorry, when we rewrite it, we'll get this piece here. Let me say it right here. Okay, so we take that 4i, let me say it correctly. So we've got x equals 4i. It'll make more sense when we have different numbers that are not the same. But if I've got x equals 4i, that means I can bring it across, and I can get x minus 4i equals 0. And that's a part of it. I can take the other one, which is x equals a minus 4i, and I can bring it across with addition, and I can get x plus 4i equals 0. And now we can use these two multiplied together to build our equation, because now these are our solution sets here, our factored forms. So we can take these and we can multiply them together, and we can get our original equation. So now we just FOIL this out. And it'll make more sense when we have one with real numbers that are different. But we take each one, we move it and set them to 0. That gives us our factors, and now we FOIL. And when we FOIL, first times first is x times x. That's an x squared. Outside times outside. You can draw ours if you need to. Outside and outside. That's x times 4i. So that's 4ix. Inside and inside. That's a minus 4ix. And last times last, well, that's a minus 16i squared. Now, what do we know about the 4i and the minus 4i? They cancel out. All right, so that gives you now, still equaling 0, that gives you an x squared. But what about I squared? I squared by definition is, remember, negative 1. So that becomes a negative 1 here. Negative and negative, then makes it a positive 16. So this is your original equation. Because if I solve this, I get plus or minus 4i, right? Because if I move that 16 over, it becomes negative. And what's the square root of a negative 16? 4i, right? Plus or minus because of the square. Now let's try another one, another example, and I'm going to change the numbers. So new example, and let's say your solutions are 5 and negative 8. These are going to be the answers. So let's say those are the answers. I want you to come up with the equation that it came from. So these are going to be the answers. So what we do is we know x equals 5, so I move it over. So my first parentheses is going to be x minus 5 equals 0. And then the other one is x equals negative 8, so I move it over. And x plus positive 8 equals 0. Now I put them together, and I FOIL, and I get my original equation. So put them back together and FOIL. And so if I FOIL here, first times first, well, that's an x squared. Outside and outside, that's an 8x. Inside's a minus 5x. Last and last is a minus 40. And so that gives me the original equation of x squared plus 3x minus 40 equals 0. So all you do is change the signs and multiply them together. It's just working backwards. I give you the solution, and you come up with the original polynomial equation. And that was really easy to do. So you just rewrite those, change the signs, and multiply them together. (29), someone asked about that one as well. And 29 is a question that we've went over many times in your homework, and I think it might have been on an exam as well. I think it was on that first exam. This is one that no matter how many times we went over, students still struggle with the setup. This is a mixture problem. And what we're doing is we're trying to work on a car that has antifreeze in the radiator. And we want to strengthen it up without overflowing the radiator. So it is necessary to have a 40% antifreeze solution in the radiator of a certain car. The radiator now has 20 liters of a 20% solution. How many liters should be drained and replaced with pure antifreeze to get the desired strength? So when it says it is necessary, that means that's what we want. And what we want at the end, when we are done here, what we want is we want 40% in the car. So we want to have 40%. As of right now, what does the car have? Well, as of right now, the car comes in the shop full, and it comes in the shop full with 20 liters of a 20% solution. Now, right now it's full, so we just can't add more, because if we added more, it would overflow. So at the end, when we're done, we still want to have the same 20. But I've got to add some pure to this. And if I just add pure in, it's going to overflow it. So whatever I add in to preserve equality, I also have to subtract off. So that's why this one is going to be 20 minus x, because that's what you got, and you're draining some of it off. And however many liters you drain off, you put back in pure. And that preserves the 20 there for equality. Now we'll write our equation out for the pure. I'm not going to solve this one because you've got it worked out already. And your pure is the amount times the percentage rate. And so the first one, it's 0.2 times 20 minus x. The second one is pure, 100%, so that's 1. So that's just an x there. And then the third part is 0.4 for 40% times your 20. And you can finish it. Because I don't see any sense in finishing it. You got it worked out. (39) and 40, I want to go over again because they're logarithms. We've done some of these, but let's make sure we know how to do 39 and 40. We've done these logarithms before, but these are the ones that you may need a little bit of extra help on. So log base 4, and I think we did this one in our homework too. So log base 4 of 4 to the 10th power underneath the square root, that equals x. Let's remember this. The square root of a is a to the half power. So we can take a square root and we can rewrite it as a half power. So the square root of 4 to the 10th power would be 4 to the 10th power raised to the half, which would then be 4 to the 5th. Because half of 10 is 5. Now we can go to convert this. our formula is y equals log base a of x, and that converts into x equals ay. There's our conversion formula. So again, we look at our logarithm and we label. That's your a. This part is the x. And this is the y. When I convert, I know it gets confusing with the x and y, but there's really no way around it. We know our base is 4, so there's that. We know our y is an x, so there's that. And what is our x? X is inside. And that's 4 to the 5th power, right? Now you should know what to do, because once you've got it to this step, if the bases are the same, then what do you know about the exponents? If the bases are the same, then the exponents must be the same. So your answer has to be x equals now what? 5. Question 40 is done in a similar manner. And then after this, we'll look at questions off of the take-home final. So we want to break this one up a little bit. I mean, you could work with it the way it is, or you can break it up. It doesn't matter. Let's see what we can do with that 1 over 49. And there again is different ways of solving. I think I may have solved it a different way in your key when I did the key. But let's look at it this. 1 over 49, well, that's 49 to the negative first power, right? Because you can flip those over. And what do we know about 49? Well, 49 is a perfect square of what? Anyone remember? A perfect square of 7, right? 7 squared is 49. So I can make this then 1 over 49. I can make it 49 to the first, and then that's going to be the same thing as 7 squared, but it's negative, so it's 7 to the negative 7, second power there. Now we can convert, because that's your a, that's your x, and this is your y. And we're going to use this formula, x equals ay. So we plug our values in. Okay, x is 7 squared. A is 7. Y is x. And I think that should be a negative there. Yep. And now we know that the bases are the same. Exponents must be the same. So x equals a negative 2. What questions now do we have on the take-home final? And I'm not going to work these out completely, but I will set some of them up if we need to.
Uh, 25.
Okay, question 25. Okay, and these are on the take-home final, so 25, question 36 as well.
39 and 40.
Okay, 39 and 40 on the take-home final, right?
Yes.
The first one. Okay, do we have any others? I'll give you a few minutes to look at these. And we'll take a short break, I think just like a 5-minute break, come back and work these out. So are there some others we need to add? Are they the same ones? Let's just take a short, yeah, we've only got 4 of them, so let's just take a short 5-minute break, get up, walk around, we'll come back. These are on the practice, or on the take-home final. I'll work them halfway out for you. So let's just take